Welcome to the topic Relations and Functions. A function from set A to set B is a relation in which each element of set A, the domain, has a unique image in set B, that is the codomain. Here, let's take an example. A relation is defined from set of integers to set of integers. Both domain and codomain are set of integers. It is defined as set of all ordered pairs x, y, where x represents an element of the domain and y represents an element of the codomain in such a way that the y, the second coordinate, should be the square of the first coordinate, that is x square. Now, let us see whether this relation is a function. Here, -2 has a unique square 4. That is, image of -2 is 4. Or we can say f of -2 is 4. Again, 2 has a unique square 4. F of 2 is also equal to 4. But we notice that every x of the domain has a unique square which is a integer. As every x has a unique y as its square, this f is a function. Now, is this function a one-one function? What is one-one function? A function f from a to b is defined to be one-one function or injective function if distinct elements have distinct images. That is, if x1 and x2 are two distinct elements of the domain, that should imply that the images of x1 and x2, that is f of x1 and f of x2, should also be distinct, unequal. In other words, in case the images of two elements are equal, then in case the images are equal, then it should imply that the pre-images x1 and x2 should also be equal. This is the definition of one-one function. Here, we observe a counter example, an example which goes against the definition of one-oneness. That is, two elements x1 and x2 I take as -2 and +2 which are unequal, but we already noticed that their images are same. 2 square and -2 square both are equal. That means f of -2 and f of 2 are equal. So we got distinct elements have equal images. Distinct elements should have distinct images to be called, for it to be called one-one function. Hence, this function is not a one-one function. This same concept can be explained through a general element method also. That is, in case the images are equal for some x1 and x2 of the domain, in case the images are equal for some x1 and x2 of the domain, then the pre-images should also be equal only if we can call it is a one-one function. Let's see what is happening. F of x1 is equal to f of x2 means x1 square is equal to x2 square. As the function says, the image is to be created as the square of the x. This equation we take further. X1 square minus x2 square is equal to 0. That is, x1 minus x2 into x1 plus x2 is equal to 0 by factorization, which gives us either x1 is equal to x2 or x1 is equal to minus x2. Notice that there exists a possibility of x1 not equal to x2. There exists a possibility of x1 not equal to x2. Therefore, f is not a one-one function. Now, is it an onto function? What is an onto function? A function f from a to b is defined to be onto function or surjective function if for each element y that belong to the codomain, there exists an element x in the domain such that f of x, the image of x is y. For every element of the codomain, there should be a pre-image whose image is present, image is same as the y element that we have taken. But here we noticed -1 is an element of the codomain, but there is no x in the domain whose square is equal to -1. Hence, it goes as a counterexample to this definition. So f is not an onto function. A function which is 1, and onto is called a bijection. A bijection is an invertible function and has a unique inverse function. So this given example is neither 1 function nor onto function, hence it is not a bijection. So the function is not invertible function, hence it doesn't have an inverse function. Thank you.